last part for differentiation, also important part for your assessment. So this part is to find the changing point, turning point in the graph. Whether this is important if you have if you're using simulation in your final years or in your experiment, you want to find what actually happened to my data. Does it converge? Does it reach a certain stable point? Or there's a consistency in my data? Okay. All right. We already covered what is dy dx. All right. Now, dy dx, y can be something, x can be something. So there are two parameters you can play with when you plot graph, your y-axis and your x-axis. For example, if you are plotting p versus h, you do dp dh, you get rate of change of pressure with height. You get rate of change of height, and so on. In your electric circuit or in your avionic later, if you differentiate current with the time, then there's a rate of change. If you have time, then rate of change, velocity also same. Yeah, temperature also same. The theta dt. Okay, so for the few slides is still doing dy dx, but the rate of change here is the changing of the rate of change here is always divided by t, by time. So distance you divide by time, you get velocity. You take the velocity divide by time, you get acceleration. Okay. In static or dynamic, you need to calculate the rotational rate of change of angle, d theta dt, and so on. Okay, the rest I'll let you read lah. So means this one, if you find rate of change means you change, you dl dt, then do whatever you learned in the previous chapter. Okay, in this one is rate of change of length. So in this case, you are given L and theta. So basically y and x, so dy dx is the same. Okay, and then substitute what is your x inside the equation. This is more application, more on application, meaning you're changing your y equal to something, x equal to something. Okay. Okay, so this also same, dy dx, you need to identify what is your y, what is your x. So if you are given I equals something, so your I equal to y, v equal to x. So you do dy dx. Okay, and if you see the rate of something per volt means per this one, di dv, then you substitute value there. Yeah, so this is more on English lah, English interpretation into mathematics. Yeah. This one, your homework, go and read. This one, you familiar? Yx, distance, time, velocity, acceleration. You learn this one in your physics already. Yeah. If you have a question, come and ask me. It's just a revision of physics. Okay. This one in your static lah. First few chapter, you see del x, del t. Okay. Okay. So you're already familiar. In your static, you learn how to calculate the velocity with the distance, change the velocity into acceleration, and then you should already know how to plot the v versus t graph, the motion graph, right? In mathematics, we don't test you that. Okay. You have seen the formula x equal y equal to x equal to function of t. So if you see f comma means differentiate one time, f comma comma means successive differentiation, and so on. This one you read. This one also you read. This one nothing complex. You read. This one you see this one in your static already. I go very fast this one. Right. Okay. It's all these are dt, something dt lah. Okay, this one you read. This is very, very important. There's one question for turning point. Okay, what I mean by turning point? Means you know curve, right? Where is the turning point? P, Q, and R. R we don't know lah, but if from here, what is confirmed is P and Q. Upslope, we call it positive gradient. So in the exam, you need to tell me, is that the upslope or that is negative? Is that a positive gradient or negative gradient? Maximum point, minimum point, and so on. Okay, gradient. This is y versus x. In a graph, how you find gradient? dy dx. Right, dy dx is your gradient, or your y equal to ms plus c. The gradient m is a change of y divided by x. That is called rate of change. Another word of rate of change is also very famous in mathematics. It's a grammar that we use to test you gradient. Actually, you are finding gradient, but sometimes we use the rate of change, determine the rate of change of something. Okay, so O to P is positive, N positive, go up. P to Q is negative gradient, then Q to R positive gradient. Okay, so maximum point P, maximum minimum point is Q. This one physics you know, but how you prove it mathematically? You need to show this competency in your final exam. There's a way. There's a way. Okay. This slide is important because you'll be asked to find where is the maximum point, where is the minimum point, where is the inflection point by using differentiation formula. You need to do differentiation first time, f comma and f comma comma, successive differentiation, to identify the characteristic of maximum point, minimum point, and inflection point. Okay, now in general, what is inflection point? Maximum point, you know lah. What is, when you have a maximum point, what is the gradient on the left? Positive. And maximum point on the right is negative. So when your differentiation dy dx on the left is positive, or we call it change of sign, we have positive, negative gradient, that is maximum point. Means it's changing from maximum positive gradient to negative gradient, that is maximum point. And you know that maximum point, later there's a way to find it. Inflection means what? Inflection means the gradient before and after is the same. Not same, but if it's negative, negative, it's positive, positive. Minimum point also same. Minimum point, left hand side is negative, right hand side is positive, but dy dx is a straight line. It's a straight line. Tangent point here. So I flip to the important things. The rest you read. The rest is read. So point of inflection means gradient at both at left or right side of that point is the same. You need to prove mathematically using dy dx and d square x, d square y divided by dx square to find the value and then prove. On the left is this, on the right is this. So it is point of something. Okay, this slide is important. This is to find whether it is maximum or minimum. First, copy the equation given. Yeah, first copy the equation. Then do like normal mathematics differentiate chapter. Do the first dy dx. Okay, this is the first step. You copy the equation. Every time you see the question, do not give you graph. It just give you a solution. Give you a y equal to something. Then straight away you'll see A, find maximum point. B, find inflection point. If have, I need to prove whether there's an inflection point. D will ask you the analysis question. What does it mean? That one. So the first point on the graph, you need to find maximum point or minimum point. As you can see, there's a straight line. So the first dy dx equals 0 means you are finding either positive or negative. Okay, you'll find a point equals 0, then you are not sure yet whether it's positive or negative, but it's one of it. It can be both positive, it can be both maximum, it can be both minimum. It can be one minimum, one maximum. Okay. First step, second step. Third step is to substitute to find that particular location. First, copy equation, do dy dx. Second step, dy dx equals 0 to find the condition of that one. To find dy dx, you'll get what is your x. Substitute your x inside the y equation, you get the coordinate of x1, y1. It's the first step. Right? So first step, dy dx, what you get? Dy dx, you get gradient. And then you adjust your gradient, becomes 0, means this is gradient, and then 0 is maximum or minimum point. You don't know which one. But when you become 0, you have an equation. You have an equation here. You can solve for x. So either you get this point or this point. Substitute lah, then you'll get your y value. If you have quadratic, you have 2 points. Polynomial, a minimum 3 points, and so on. Yeah. Next one, you need to do we need to do analysis. So these 2 points, they are dy dx equals 0. These are the steps. First step, you need to do dy dx equals 0. Then the next steps, you need to tell me either which point is positive, negative. Which point is maximum, which point is negative. Okay, so, and you need to sketch the graph. You need to know how to sketch the graph. So, this is another slide which is important. Just now you do dy dx. The next step is to successive differentiation where you do dy square dx square. Means you do f comma comma. Okay, second step is this one. After you find dy dx equals 0, you find 1 point or 2 points. After you equal 0, dy equals 0, you find what is your x. Then the next step is to further differentiate one more time. You get 3 answers. You differentiate one more time, there's 3 possibilities. Either the value is 0. How value get 0? When you get dy dx equal to numbers. dy dx equal to 100. So d square y dx square, you get 0. If it's 0, it is inflection point. If it's less than 1, it's maximum point. If it's more than 0, it means positive value is minimum. Negative value, you get maximum. So have a note, some note inside your revision notes. You do dy dx, there's two possibilities. How you justify whether it's a maximum point, you differentiate one more time. If you get value, I think my slides. My notation a bit contradict to each other. Wait. Or dy dx positive. Positive, you get maximum. Negative, minimum. I confused with my own slides. Okay. Means you differentiate 2 times. If the value more than positive value, means positive more than 0, that is the maximum point. If you get negative, means minimum point. If you get 0, it's inflection. Inflection, there's a test for that also. Another part. Just to leak the question for you. Part A, you do up to here. Up to here. You need to prove, you need to justify that point is positive, negative by this statement. This statement. So you find the square y over the x square. You find the value. So, or you use a 3 dot there. So that point is maximum or minimum. So it's 0, inflection. This slide is important. So again, if you get 0, don't too excited. It can be more than one location that have inflection. So don't stop there and then try to see how to determine. Okay, what is important so far is these slides and these slides. It's the most important slides in this session. Okay, copy the equation, differentiate one time, find what is equal 0. Equal 0 means you're finding maximum, minimum. Then you do dy dx. Again, you get 3 possibility, either 0 and positive value and negative value. Positive value, maximum point. Negative value, minimum point. It is 0, then inflection point. Okay. Now, if you have inflection point, the further step is to do hypothesis. You test left-right point. How to do test left-right point? You will be given, you'll be finding what is that inflection point, right? How to find inflection point? If you have dy dx, d square y dx square equals 0, normally in that direction, in that equation, you can find either it's linear. If it's linear, only 1x. If it's quadratic, you have 2x. If 2x, use the quadratic solution to find the x. Yeah. Okay. So here, you need to check, is that a change of gradient? Okay. Change of gradient. This one we already done. This is already done previously. Okay. So this one is another check. You can skip this step if you already done this one. Either you use this reason to justify it's a maximum minimum point, or you can do hypothesis. You check gradient before and after, before the point. Yeah, this is a bit lengthy, yeah. Not highly recommended for this step, but if you want to do, also can. Okay. The rest you read, huh? The rest you read. Okay, I'll show you one example. One good news for a final is this for this turning point question, you won't see trigonometry question. You will be seeing quadratic, polynomial question. Means I think maximum also x power 4 maximum. But I will give you more detail when you come to final. During revision time, I will let you know. Okay, observe how we do. Always the same one. So if you're given an equation, y equal to x power 2 minus 6x, this is to determine the sign of gradient on other side. So doesn't care. You only need 3 steps only. First, write the equation. Second, differentiate one time. Doesn't care. Differentiate one more time. You do dy dx, then do the square x over the x square. Differentiate 2 times. Then you observe the numbers. Okay. You do dy dx. You'll get 6x minus x. So you know that at turning point, maximum or minimum, gradient is 0. Inflection cannot be 0. Inflection is either continue go up or continue go down. So if inflection dy dx not 0, unless you get a flat line. Flat line. So at turning point, dy dx 0. So this one equals 0. You only have 1x. So x equal to 1. Substitute back. You want to find coordinate. X1 inside this equation, you find your y. Then you get your x1, y1. Put in the bracket the coordinate. So you tell me, so need to write this sentence in your final. You need to, if you're lazy to write this long, at least you write the turning point is bracket x1, comma y1. Means the coordinate that you calculate. Okay. So this is turning point. You can test whether it's maximum, minimum. Okay. Okay. So the next slide here is not highly recommend to do, but this is a slower way where you know that your x is 1, right? Your x is 1. So you do one point which is on the left, 1 point on the right. So your x is 1. So you use 0.9 which is on the left, and then you use 1.1 on the right. You substitute inside, you get your gradient, right? So on the left, your gradient is negative. On your right, your gradient is positive. So negative, positive, minimum. Means on the graph, you roughly you can sketch the gradient. Okay. So here you can write based on this hypothesis. Slightly to the left, sorry, to the right, you get this negative positive. So that point is minimum point. Or another method, this one. Both give you same marks. Both give you same marks. Either you use this method, with the slower method also correct, or you use successive differentiation, which is double differentiation. So double differentiation, you get 6. 6 is positive, right? So positive is sorry, more, not positive, more than positive is minimum. Okay, so point minimum with the positive, minimum is negative. Okay, understand? Can I? Okay, so understand this one. We go for one more, which is inflection. This one your homework. Homework. Lots of example lah. Go and see. Still same, the yellow box is important. You need to write in your answer. Expect you need to sketch the graph, something like this. Not scalable, but the shape must be there and the point on the x and y must be given. Okay, inflection. Hey, where's my inflection? I try to find the inflection for you. The inflection. But basically, you get the idea lah. Get the idea. Okay, so like for example, this graph. Okay. So understand this one. Use this yellow box to prove your statement. Just for info, final, there's one section you need to prove whether got inflection or not. Okay, application, I just go very fast. So application, if you use the maximum minimum means minimum area. Still same. Still the same. If dy double differentiation, positive value is a minimum. Less double differentiation, you get negative number is the point is maximum. And if at inflection, then your double differential equals 0. So go home and read this one. This application is important when it comes to your IDP or your integrated project. Okay, you do design later. The rest we have a look, right? Have a look how you apply the things. This is in your design module. You need to design something, you need to find a minimum material that you can use, then you use differentiation. Okay, so we expect you to apply this one in your final. Meaning there's a quadratic equation in your final. So okay, let me see anything I need to stress. 4D question, 3D question will be this one in your fluid mechanics, hydraulics. Later you see this one in your fluid mechanics, especially piston. Piston question. Okay, this one, have a look. Go and read. Go and read. If not mistaken, last part of the question will ask you this maximum minimum point, how it affect your design or something like. How it help you to determine the minimum area or minimum volume and so on. You just need to elaborate a little bit on the application of this chapter. Okay. The rest is have a look. This one might be a bit fast for those viewing the recorded video. But those in the class, you can download from Island the slides. This one. This one will be maybe in your final year satellite operation later. With this one, something like this. Okay. Have a look. This one, have a look. Inflection. Just now I find this inflection. Continue just now. This one, I just show you one example, then I think we call it a day. This one, got something inside your final exam. So determine whether this equation got inflection point or not. So again, equation, first differentiation, second differentiation. If the question asks you to determine got inflection or not, it will be equal 0. Straight away, the second differentiation equals 0. So first, write equation. Second, do first differentiation. Third step, do another differentiation with double differentiation. You'll get 3 equations. If that question asks you point of inflection, meaning you already done the dy dx things already. Inflection means this one equals 0. So from here, if there is an inflection, means your double differentiation will be equal 0. So meaning this equation, 6x minus 12 is equal 0. So there's a value of x there. If you get a value of x there, means there's an inflection. But of course, when you get complex number, then unsolvable, don't have inflection number. Or this one, you won't get anything there. You will get some very weird equation. Then there's no inflection. So in this case, you have 1 point there. With this x equal to, remember 5 coordinate. This chapter, you need to always write your final answer in the coordinate format. Bracket x1, y1. Close the bracket. Okay, once you find your x, find your x, then you need to test. You need to test. Don't stop here. If the question you already found 1 point of inflection already, next, because if you see the marks, you already know already. Second session, let's say there's 11 marks to find inflection. Don't stop here. You need to do testing. With this, you find 2 points, 1 point on the left, 1 point on the right. Means your x is 2, find 1 point, less than 2 on the left, which is 1.9 or 1.8, doesn't matter. Then find one point which is on the right. In this case, you can put 1.1, 1.2, doesn't matter. Even you put 0.01 also correct. Okay, once you find that, then you know there's a value for your double differentiation. On the left, if your x equal to 1.9, you substitute inside there, you get negative sign. And on the right, this one on the right, 2.1, you get positive. So what 1.9 give you negative value, 2.1 give you positive value. It just means there is a change of sign. There is a change of sign. So you need to write this one. There is a change of sign. So the point of inflection exists at x equal to, or x equal that one. This statement you need to write. After you do testing using point, left, right. Maximum, minimum point, don't need to do this test. But if in the question of inflection, you need to do. This one? This one, is it? This one. No. This one means that the coordinate of 2, x1 equal 2, and of course got 1 y lah. So inflection happen at x equal 2. Means you can put that location also. 2 something. Y is, if we substitute 2 here, y equals something. Right? You can either write like this, x equal 2, or at bracket x1 comma y1. That where you substitute x equal 2 inside this equation. Understand? Justin already lost. Yes. Yes. Okay. Inflection, you use double differentiation to see change of sign. Maximum, minimum point, you only use the first differentiation. Gradient. Negative, positive to negative means maximum point. Negative to positive is a minimum point. Okay. So meaning first section of your final exam question, this one do not apply. This is second question. Second part of the question. This one only apply for inflection. Because the final question a bit tricky, it put in the sense of gray area. If you think got inflection, then you do. If you think don't have, you just write no inflection, then you skip to C. But for your info, there is an inflection. So if you skip, then you lost that, I think minimum 10 marks there. Okay. If no question, I think we come to the end of the chapter. This one. You can either write inflection at that point, 2, 7. 7 is when you substitute your 2 inside here. Okay, the rest you have a look lah. Yes. Yes. Ada. Wait. Wait lah. Jadi. Relax. Okay. Okay. This one we continue next lecture. Yeah. Okay. We stop here. We go for quiz. Let me see if I. Okay. I have a quick one. Sorry. Okay. Tangent. How to find tangent? Okay. It just means if you already find a line, if you already find a tangent line, how you draw the blue line? Do you still remember what you learned in your SPM? Or forget already? You still remember? Okay. You still remember M multiply M1 multiply M2 equal to -1? Yes. So this is for tangent. Okay, this section actually to convert. If you're able to find the red line, y equal to mf plus c, you want to find the blue line, what you need to do is to flip the gradient into -1 over m. How to find 1 over m? It is m1 multiply m2 equal -1. Means if you have tangent to two line that is perpendicular, the gradient of red line and the blue line is -1. Okay, just apply this one. Yeah, so this slide is conclude this slide. Okay. Yeah. Okay, one more before we give. Okay, small changes where you see in the this one you already seen already lah. If the question asks you small changes means delta something, you can use this sign. Curly sign means very near to dy dx. But if you want to change to dy dx, if you want to change to equal, you use limit. You apply the limit equals 0, then it will become equal dy dx. But this case is just if you want to calculate small changes, this is the equation that you can use. This one usually in the fluid mechanics. Okay, so small changes. This is the slide for the chapter. And for your info lah, you go home and read. For your info. So basically, you have a look. When you know you need to use delta, you see the question asks you to find approximate changes. Then you apply this formula. Delta y, delta x, curly, very near, approximate to dy dx. Then you substitute the value there. Yeah, this is when you see the question asks you to find approximate changes given an equation. You do dy dx. Then how you know how many x there or how many x there is in the question? So delta x is 0.2, 0.02, 0.02. Substitute. Answer for this question is 0.4 with a curly sign because the question asks you approximate. So you cannot use equal when we come to this section. Your final do not cover here. Not cover. Not cover. Huh? Okay, the rest you read. Got question, come and ask me. Okay, with this we conclude differentiation. Okay, I'll give you a quiz. Huh?